Hi, welcome to our presentation. This presentation is going to talk about an exciting and growing field in engineering today, also known as computer systems engineering. A computer systems engineer combines his or her knowledge of engineering, mathematical analysis, and computer science to develop, test, and evaluate circuits, software, and personal computers, and more. A computer engineering degree graduate usually works as a computer software engineer or a computer hardware engineer. A computer software engineer creates a software that translates commands from applications into instructions that the hardware can understand. A computer hardware engineer researches, designs, and tests the physical components of a computer, including circuit boards, chips, and keyboards. They also ensure that the physical components of a computer that they create will function within the parameters of the latest software developments. Computer systems engineering falls under the main engineering branch of electrical engineering. Electrical engineering is one of the newer branches of engineering and dates back to the late 19th century. It is the branch of engineering that deals with the technology of electricity. Moreover, electrical engineering deals with the study, design, and application of equipment, devices, and systems which use electricity, electronics, and electromagnetism. Electrical engineers work on a wide range of components, devices, and systems, from tiny microchips to huge power station generators. Computer systems engineering contains 4 subdisciplines. Number 1, electronic engineering, which deals with design, fabrication, and operation of circuits, electronic devices, and systems. Number 2, computer engineering, which focuses on solving problems and designing hardware and software interfaces. Number 3, power engineering, involves the generation, transmission, and distribution of electricity and the design of devices. And lastly, optical engineering, deals with the design of instruments and systems that utilize the properties of electromagnetic radiation.
A computer systems engineer develops, tests, and evaluates software and personal computers by combining their knowledge of engineering, computer science, and math analysis. Contrary to popular belief, computer systems engineers do not merely engineer computer technology, rather they are expected to fully comprehend how that technology is used on a wider scale to suit both personal and professional requirements. Now, some examples of projects that a computer systems engineer might employ would be making hardware and software recommendations for the implementation of a new inventory tracking system. Additionally, they may assess a company's CRM system and design a system to optimize or scale to the company's current or future needs. Finally, they may transition government systems to updated servers and programming languages based off the needs of the system and the requirements of the organization. The knowledge and capabilities of a computer systems engineer lean heavily on other engineering fields. A majority of the projects that would involve a computer systems engineer would require the use of tools or products designed and created by electrical engineers, such as circuit boards or other hardware solutions, or software engineers, such as pre-built software applications to fit their current needs. In more situational cases, and depending on the project, computer systems engineers may also benefit from the data generated by systems engineers to glean data on current systems and requirements, process engineers for ways to best optimize, and mechanical engineers to integrate mechanical components in things such as assembly lines. The computer systems engineer leverages their wide understanding of multiple disciplines to design systems from the tools or components created by these other fields, and by doing so are able to accomplish much larger projects in a much shorter period of time. Becoming a computer systems engineer generally follows a traditional pathway of college, internship, and experience to break into the field. A 4-year degree in electrical engineering, computer engineering, and information technology will be required. Master's or doctorate's degree may be required for some higher positions. Being a highly interdisciplinary field, certifications in various hardware and software tools and applications can be helpful for specific positions. It's going to require a strong interest in math and sciences, as well as strong communication skills. There are a wide array of societies related to computer systems engineering. 3 of the most common include the Association for Information Science and Technology, or ASSIST, the Association for Computing Machinery, and the IEEE Computer Society. ASSIST helps members build skills and develop their careers through training, research, publications, and ongoing education. Association for Computing Machinery helps to bring together computing educators, researchers, and professionals to inspire dialogue, share resources, and address the field's challenges. And the IEEE Computer Society is there to advance the principles and practices of systems engineering as applied to development and sustainment of computer-based and software-intensive systems.
There's a very diverse skill set required when pursuing a computer systems engineering degree. There are a few key things every individual should take into account. For starters, there's actually a lot of skills required when pursuing a computer systems engineering degree. Some of the key ones include knowing how to maintain a system and its security, checking for vulnerabilities within a particular software or application, writing scripts that increase system efficiency, and installing and configuring operating systems and application software. Though there are many more technical skills required, there are also a lot of soft skills, including having good communication, especially if you're working with a team, problem-solving skills for when issues arise, and good work ethic and the ability to work efficiently. There are plenty of universities you can attend in hopes of achieving your computer systems engineering degree. I listed a few on this slide, but there are hundreds of universities offering this degree. First on the list, we have Massachusetts Institute of Technology, or MIT. Located in Cambridge, Massachusetts, this university is ranked number 1 for computer systems engineering and is a very well-known institution, known for their numerous high-ranking engineering courses. Next on the list, we have Johns Hopkins University, located in Baltimore, Maryland. Then after that, we have the University of Texas, located in Austin, Texas. And then the university we're probably all familiar with is ASU, or Arizona State University, located in Tempe, Arizona. And last but not least, we have Ohio State University, located in Columbus, Ohio. And these are just a few of the numerous amount of universities and colleges that offer degrees in this field. When pursuing a degree involving engineering, it's always good to have some hands-on professional experience under your belt. So anyone hoping to maximize their learning experience should look into applying for various internships and REUs. This helps students get a grasp of how their major will feel in a work environment and also provides them with the experience they need to excel in their career outside of college. For starters, ASU offers a major internship program which provides undergraduates with hands-on experience in their field, helps students enhance their personal and professional skills, and increases students' likelihood of employment in their major. Next, we have REUs, or research experiences for undergraduates. REUs help provide undergraduates with a professional atmosphere to help accelerate their learning and understanding of their major. If you'd like more information regarding REUs and how to apply, you can visit the National Science Foundation's website and navigate to their institution's REU programs.
In order to better understand computer systems engineering, we conducted an interview with Sean Barron from Public Safety Personal Retirement Systems, who's been working in the field for over 30 years. Now, when asked about his inspiration for pursuing computer systems engineering, he said through his academic career starting in 1983, he always pursued science, but enjoyed computer and programming classes most. He also noted most of his courses more and more began to rely on some kind of computer application, and after college, the jobs were so plentiful in the field, he never ended up pursuing anything else, and it always felt like a natural fit. And when asked about how students can get an internship, he replied, "I always look for a very strong base of core competencies and a personality that I think suits the team. Everything else can be taught to such a person." When we asked, what do you still value from your college education and how does it help in your career, he replied that very little of his core education was still applicable by the 90s, but core engineering principles and effective communication skills continue to remain relevant. And when asked, how do engineering principles help you in your work as a computer systems engineer, he said that problem decomposition, scientific method is applied to testing, troubleshooting and design, and effective communication were some of the most important aspects to his everyday job, and that understanding the underlying structures of what happens very much helps in all of those aspects. Now, finally, we asked him what his advice was to a student breaking into the field, and he said that understanding core concepts, while maybe not directly applicable, will still improve an engineer's ability to deconstruct a problem and come to a better solution. He said one of the most important things that any engineer can have in his tool belt is the ability to continue to learn effectively.